Um, can you describe which tool are provided in the new version of Visual Studio to see this task?
Yeah, absolutely. So there's a whole bunch of stuff shipping in Visual Studio 2010. I would start with sort of the core execution platform. On the native code side, we have something called the concurrency runtime, upon which the scheduling technology is built, the resource management technology is built. It's all incorporated into the concurrency runtime. On the managed code side, we build a lot of that technology directly into the .NET Thread pool, and we can
both Resource Manager and scheduling.
Yes, we use the facilities already provided in many ways by the .NET Thread pool. We taught it some special tricks that are available that aren't used by the standard Thread pool. And so things like work stealing, for example, which is a concept that the task APIs use. And what work stealing allows is a more balanced usage of resources across the machine. So if I've got say I've got this thread pool inside the runtime that's servicing, I've got a quad core machine, so there are 4 threads servicing all my tasks and executing all the tasks. When one of those work queues runs dry, it knows how to steal work from a neighboring queue and execute it so that all of them are kind of constantly busy as much as possible. So that's all technology that's built into that core execution platform. On top of that, you can think of both native and managed code pieces that are very comparable. So the task-based APIs are very, very comparable. There are some small differences in syntax and in patterns and how you use them, but basically they provide a task abstraction that you can program to instead of threads. And then they provide higher level abstractions on top of that in the form of things like parallel iterations, so parallel for loops, parallel for each loops, again, both native and managed code. And then there's a piece where the native and managed sides differ. On the managed side, we've got a technology called parallel link. So it takes link, allows you to execute link expressions on local data in parallel. So basically you just get the answer a lot more quickly. Usage of it's really easy. You basically kind of take your link expression and say dot as parallel as a part of your link expression, the enumerable on your link expression. And the magic underneath the execution platform kind of knows how to do the work for you. On the native code side, we have a technology called asynchronous agents. And what asynchronous agents is allows for an actor message type of programming model. So we talk a lot in parallel computing about shared state and how do we manage it and how do you get as efficient as possible relative to locks, and can we do lock-free algorithms to prevent bottlenecks in the system. Asynchronous agents takes a different approach. It says, hey, managing share state is hard, so don't do it. Instead, you can construct your application as a series of totally disconnected agents that don't share memory with one another. And the only way they communicate is via message passing.
Yeah, I see a new technology, but it's in incubation called Axum.
Yes.
And Axum seems very great about this model. Have you some information about Axum?
So Axum is an incubation project, as you mentioned. I believe we have it available on our DevLab site, kind of our dev div. This is kind of the cool stuff we're working on in the labs. Part of what Axum is it's similar to what I talked about with asynchronous agents. It's a programming model that allows you to
For me, it's more advanced because you can connect several agents, cross machine, cross process. It's not possible yet with C++ agent.
That's correct. You'd have to roll all of that yourself if you were to do it in C++. The other thing Axum provides that's not in agents is this sort of notion of contracts between components.
It's very important.
Absolutely. And this is just an incubation technology right now, so we don't necessarily have any plans to ship it. But one of the reasons we put it out there is we thought it was an important step forward in terms of helping people think differently about how to construct applications that are sort of more parallelizable by default and more scalable by default, as opposed to having to do all this shared state management. And so we're interested in feedback on the technology.
You're right, but as you know, Axum is very similar about concept, about Erlang, because Erlang is the big success.
Yes.
And I suppose some people are using Erlang today. Have a look about Axum. Axum proposed some new feature like domain, like contract, very advanced to have a safe and scalable application. And I suppose Axum will be a success if it is released.
Yeah, we'll see. Wow, it's getting busy. We get that comparison a lot. We also see some comparisons, people looking at asynchronous agents and going, I get it. You're doing something similar to Erlang. And of course, that's kind of, whenever you look at one of these agent message-based programming models, the first comparison that people tend to make is with Erlang, which is in many ways the granddaddy of all of these.
Yeah.
So yes, there are a lot of folks on the team that are big fans. A lot of folks think it would be a success. For us, it's trying to pick the right combination of features for the next revision to see. There are a lot of things we could do, frankly, and there are way more things we could do than we have people to do them. And so for us, we're going through the process now of trying to figure out what that might be. Is Axum in the mix? Is it not? We just don't know.
Okay.